Okay, so this last page is also going to help us to review. It's going to help us to see, okay, imagine that I have methane and I know that there's 1.5 moles of this sample. Now actually from that we can figure out how many particles there are, we can figure out how many liters there are, we can figure out the mass of that sample. And so we want to figure all those things out just from this one piece of information. And then when we're doing that, we're going to end up using the formula mass so we can figure that out from the periodic table. So this is again going to be a helpful piece of review for us. So we'll put that aside. At the bottom of this, there's this helpful little chart that helps us to figure out what are the pieces of information that go together. So for example, if we're trying to figure out the number of particles of something, then we can look at the number of, but we know the number of moles. Then the way that this is designed to work is that I can cover up moles, because this is what I know, and then I'm going to look at the number 6.02 times 10 to the 23rd to help me to figure out the number of particles. Okay, we'll erase that. And then if, for example, I know the number of grams that I have, then I could cover that up and then I can use the formula mass to help me figure out the number of moles. And so these numbers, 22.4, 6.02 times 10 to the 23rd, and the formula mass that's going to come from the periodic table are going to be really helpful in helping us to transfer from one to the next. So we're going to put that aside too. And now we're going to look at one of my practice problems. So this one is, if you look here, again, the methane, I started with the moles of the sample, and imagine I'm trying to figure out the part that tells me about the particles. So here I have the moles of the sample I know is 1.5 because that's on the chart, and I have already here covered up the number of moles that I have, and then to figure out the number of particles, I'm going to use Avogadro's number, 6.02 times 10 to the 23rd. So then these two things are equal. 1 mole is 6.02 times 10 to the 23rd molecules. So I can do 1.5 moles, put moles on the bottom, so then that these two will cancel out. And then I will end up with 9.03 times 10 to the 23rd molecules of methane. But then I want to look at the beginning. I can see that my significant figures here is 2. My significant figures from Avogadro's number is 3, but since 2 is the least number, I'm going to go with that. And then I will have the answer 9.0 times 10 to the 23rd molecules of methane.